Hello everyone, my name is Yuqian Wang, and today I will present my project titled Emotional Dynamics and Spatial Progression Around the World in 18 Days. This project expands my previous work by adding method and compression and some automation using modern NLP tools. The main goal of my project is to understand how emotions change throughout Jules Verne's novel and how those emotions move with geography. I want to answer three questions. First, how does the emotion tones rise and fall across chapters? Second, do different sentiment dictionaries give similar patterns? And third, can geography, like cities or countries, explain these emotional shifts? Several key studies inspired my work. Jokers used large-scale sentiment tracking to show that emotions in literature can be codified. Underwood emphasized distance reading, which studies patterns across many texts instead of close reading just one. Rabra reviewed both lexicon-based and machine learning approaches and remind us that interpretability is still a big issue. And Bisonnet compared dictionary methods with transformers models such as BERT and found that while contextual models capture subtle emotions, lexicons are still useful because their results are easy to explain. My project builds on these findings, combining lexicon-based and spatial analysis while keeping interpretability. I started with the project Gutenberg text of Around the World in 18 days. I cleaned the text by removing chapter headers, punctuations, and the footnotes, and then turned everything into lowercase. Each chapter became one text block. This cleaning step ensured that my segment scores reflect the actual story, not the actual formatting. After cleaning, I used for common lexicons, NRC being uh, Aving and Vendor. Each of them scores words differently. NRC focuses on emotion categories, being labels words as positive or negative. Aving gives numeric scores, and Vendor handles intensity and negation. By comparing these four, I can test how much the results depend on the tool itself. And the sentiment score per chapter. This formula shows how I calculate the sentiment score for each chapter. Here, N is the total number of words in the chapter, and SW is the sentiment value of each word given by the uh, lexicon. By averaging all these word scores, we got one overall sentiment score per chapter. This helps us compare emotional intensity and directions across different parts of the world of the novel. So the average correlation across lexicons was about 0.78, meaning their pattern are consistent but not identical. All analysis was done in R using tidytext and dplyr and ggplot2. So why I use that package and some comparison with other tools for visualization, I use a SUSAT package, which is often used in digital literary studies. Compared with other packages like Vendor or Text Blob, SUSAT is better at showing smooth emotional arcs across chapters. It fits the structure of a novel, showing how tension rises and falls as the story moves forward. So that makes it ideal for a book to like Werner's, which is full of travel and adventure. This is the result and interpretation. So here you can see the sentiment trend across all chapters. The pattern rises and falls just like a journey. There are peaks of excitement and depths of crisis. High points often happen when frog achieves progress. Low points appear when delays or conflicts occur. So this wave-like rhythm reflects Werner's adventure style: tension followed by resolution. Next, I integrity geography into sentiment analysis. This is location mapping, and the purpose is integrity geography into sentiment analysis. So I identified key places like London, Bombay, Calcutta, and New York, and labeled each chapter with its main location. I then combined these location tags with sentiment polarity to see how emotions change across spaces. So, for example, European shows more positive tones, while colonial settings such as India show emotional instability, possible reflecting conflict or uncertainty. Overall, the emotional journey follows the travel path of the characters. To make this mapping possible, I created a custom location dictionary of 25 major places. I used keywords and regex matching to detect them in the text and applied context rules to handle ambiguous cases. For example, Calcutta and Calcutta. Each match was validated manually to ensure accuracy. The workflow was simple: text to the keyword matching and location, then to the sentiment aggregate. This map shows how emotion vary geographically. European cities like uh, European cities like London and Paris are mostly possible, representing stability and order. In Mumbai and Calcutta, sentiment fluctuates strongly, perhaps showing cultural tension or plot challenges. Maritime and transition routes show oscillating emotions, which fits the novel's repeated cycles of crisis and recovery. So the physical journey mirrors the emotional one. The trip itself becomes a story of emotional movement. In Project B, I improved this method by adding named entity recognition, or NER. NER is a machine learning technique that automatically finds people, organizations, and locations in text. For example, from the sentence, "They arrived in Mumbai after leaving Suzy," NER detects both Mumbai and Suzy as geographical names. This automation removes the need for manual keyword list and is more flexible. It can detect multiple words names like Hong Kong Island, ignore false positive, and scale to bigger data size. It can also be integrated easily with space or Hugging face models. So compared with Project A, this project A's three main improvements. It compares for sentiment dictionaries instead of one, improving robustness. It validates results quantitatively by checking correlation among lexicons. It enhanced location mapping using NER to make it automatically and scalable. These steps allege the project with recent research in computational literary studies showing progress from basic dictionary method to more modern NLP approaches. From the results, we can see that Werner's narrative rhythm is highly structured. Emotions rise and fall with the progress of the travel. Geography isn't just a setting, it shapes the reader's emotional journey. So the improved workflow also shows that computational tools can support literary interpretation when we balance automation with human insight. Lexicon models give transparency, while NER and NLP aid context awareness. Both are necessary for meaningful literary analysis. This is the reference I use in this project, and to conclude, this project connects classical literary interpretation with modern data science. It shows that even a 115-year-old novel can be explored with current NLP techniques. By comparing tools and improving automation, I have tried to make emotional mapping more transparent, reproducible, and scalable. So thank you very much for listening.